How are you? Nice to see you. My name is Mikeal Jones. I'm a hydrologist. I worked for the Forest Service for 30 years here in Roseburg, and before that in Illinois. I went to forestry school in Arizona in Tucson and got a bachelor's in watershed management. And then I went to the country of Chile in the Peace Corps for 3 years, building stream gauges, and came back, got my master's in snow hydrology. And then I went to my first job in the Forest Service in Illinois. Wow. 5 years there. We spread Chicago sewage sludge on millions of gallons of it on strip mines to neutralize the acid spoils. Then I came here and did pretty much the same job. I was the principal hydrologist in the supervisor's office in Roseburg, and I'd go out to the ranger districts, and sometimes they had a hydrologist, sometimes they didn't. And so my main interest is in monitoring. It's the part of my job that I like the most, starting with stream gauging in Chile, I guess, and keeping track of flow and water temperature, water quality. And the title of the talk is Noticing What You See and Writing It Down, which is kind of the essence of monitoring. You can do that to the nth degree. You can take measurements over the day as it's warmer and cooler. You can take measurements over years, measured from place to place, and we'll have some examples of that, talk about it. But you can tell that I really liked monitoring. That was a thing that got me out of the office, and I could just see, the changes, and it was real objective, and I think that's something I'd like to get across in the talk is you guys are elementary teachers. I'm a hydrologist. You know how to get through to kids. I have some suggestions, but it would be good if kids could see the real world, the natural world, and remember it and document it without really taking part. In other words, they don't have to change it. They're watching, and if we pick up a fuzzy animal and love it and take it home and put it in the aquarium and whatever, we're doing that for ourselves. The animal was real happy where it was, and has evolved to that place and their habits. And if somebody keeps a bug and it dies, well, there are lots of bugs, and this is how kids learn and everything. But it's important to realize that they're important on their own, not because of how they make us feel or what we do about it. So get off my soapbox, and if I were talking to kids, I would say, well, what do you see, and are there any changes? Is it different when you're by yourself or with a friend? Your attention gets taken. You see some changes. Do you see some changes since you got here? Being on a stream or a pond or something. And are those changes fast or slow? Would you have to come back next week or next month or next year to see a change? So that could be, how high the creek is on a rock, or how much, what the water temperature is. You can measure it or observe it. I don't know how kids, I think of your pupils as being real little kids, but of course you have little kids and you have sixth graders, so there's a big, but I was thinking of writing things down like I would. Oh, kids probably don't have a phone, they probably don't take pictures. And that's a great way. You click and it's date, time, place. You can even georeference it. So if they like doing that stuff, they can build it with what they already like is good. And the last note that I had was creeks are dangerous. Falls, rocks, things are slippery, cold, and wet. I would be terrified if I were you and I had kids out there. But I suppose you've been in that situation. Each has a parent or older kids take care of younger kids, whatever. But even adults for themselves. I took a 70-year-old guy when I was in my 30s out on the North Umpqua River, and the very first thing he did was he back and fall smack on the back of his head. We had the ambulance there, and it was a big deal. So person doesn't want to not go to creeks for that reason, but it's important to remember that there's really some dangers there. So I think often kids zoom in to little things and see things more, maybe focus and get their attention on things maybe better than adults do. We have their heads buzzing around with things. So capitalizing on that and asking them what they've seen and such, but keeping track of that is monitoring. I just love hydrology. So for me, if I were a teacher, I would be looking for those aha moments when things click, and all of a sudden they really like what they saw, and it makes an impression. So the version I was in grad school, and a professor took us out into a bunch of trees, pine trees, and said, okay, we all know how to measure rainfall, put a rain gauge out in the open there. What happens if you put a rain gauge under the trees? You're gonna get much rain. Where's the rest of it? Well, we could put collars on the trees, and as the water runs down, we'd get it, and then all of a sudden, I got an inch of water in a can, but I've got a liter or a gallon of water in a jar. And how do I compare an inch over this area to the gallon that came off of this one tree? And it was real quantitative. There's a good way to do that. The tree has a square area, just like the can has a square inches of area, and you can compare those two. And so we did. We figured out that we didn't measure it all. Where'd the rest of it go? Some of it stayed on the trees and evaporated back up. It was very quantitative, and it just hooked. I mean, I can remember that as the flash. That got me into hydrology. So 40 years down the road, does a lot for you. So if a kid decided that they really liked insects, water insect, birds, that would be something that they would relate to and might be their aha moment. Let's see, can I advance this with the arrow, or how do you? Oh, there, yes. Okay, so we're talking about being somewhere, measuring things. That's a stream gauge on the North Umpqua River. Measure stream flow. The woman in the creek has stretched. That's a very tiny creek. Might have less than 1 cubic foot a second. It's really hard to measure, but it takes about 2 hours, even though it's 2 feet across. You have to take a measurement 20 times across there with a little instrument that has cups that turn with the velocity, and you measure the depth and the width and the velocity, and you come up with so many cubic feet per second. So you do that, and we did that on 9 different creeks in Steamboat Creek for 40 years. At least one time a year during the low flow period in the summer, and there was a recording stream gauge on Steamboat Creek, so we kind of knew where we fit into the year's flow. And this is the kind of thing that we got. So this is looking at variation over years. So it's from 1969 to 2007 across the bottom. The temperature in Fahrenheit up to 80 degrees. And that dark line is Steamboat Creek. So it's a big creek. Bigger creeks are normally warmer than smaller creeks. The further they travel, and especially they get wider, so they're not shaded as well. pretty warm. So up there, and over time, things look like they changed to some degree, not as much on Steamboat as Cedar Creek, which is the smaller one. Cedar Creek was our poster child for the big mistakes. You know, that all the trees were cut off Cedar Creek, all the big tall Douglas fir, and sometime in the 60s. So they went out and measured it, and sure enough, you know, it was 80 degrees. It was just as warm as Steamboat Creek was. Over the next 10 years, you can see that lighter line with the triangles coming down. Alder, small trees grew up pretty fast. During the summer, they'd have leaves, so there'd be shade. And it cooled down, you know, over 10 degrees. You can see that over the years, just naturally, there were some cool years like 1983 and 1999, 93 and 99 were just naturally cooler years. They probably had to do with more rainfall in the winter, so the stream had more water. So the same amount of heat, even if it was just as warm as summer, same amount of heat got diluted, got dissolved into less water, or I mean more water, and so that made the water cooler. So Cedar Creek continued to cool a little bit and got down to where it was before the trees were cut off, down at 65 degrees. Steamboat, because it never was completely shaded and it had lots of other creeks at varying degrees, not as bad as Cedar Creek that had their trees cut off. It stayed up there bouncing around, and it looks like we've had some pretty warm years in the last few years, but natural resource data is messy. You know, you got a lot of this variability that you have to explain, and I could have showed you this first because Cedar Creek is in the middle there. And this is just one day in 1969 at one time when Cedar Creek was 76 degrees, and all the other streams were, you know, as warm or a little cooler. The dots on Steamboat Creek get denser as you go down, and the dots, where the dots are dense, either in Steamboat or in Little Rock and Cedar Creek, that's where the water's warm. When Steamboat Creek got to Big Bend, it was 78 degrees, but Big Bend, for some geologic reasons, there's deep soils and has just a gush of cold water coming out. It was 64 degrees, so it's, you know, more than 10 degrees cooler. And sure enough, Steamboat drops from 75 to 70. And if you've ever been up Steamboat Creek, there's a pool right there, right below Big Bend Creek, with 50, 60 steelhead. Summer steelhead swim around all summer long, and they like that pool. They stop there. You know, they don't go up where it's 80, but they're all set to go up next winter, up the tributaries when everything's cool, and Eureka reds and swan. By the time Steamboat Creek gets down to the North Umpqua River, it's 76 degrees again. And if you plot that a different way, and this is just by way of saying, you know, sometime in those elementary years, some graphing and some photographs and things are going to be introduced, and they can be a lot of different kinds of graphs. So one was a map. I always think of maps and graphs as a thing that is a picture that's easier to understand than words. I've only, as I've gotten older, found out that they cause some people to just tighten up, and so it'd be good if kids got comfortable with them early before they get scared. So this is a longitudinal graph of the maximum weekly temperature at a different time in Steamboat Creeks, and some of these are warmer. Let's see. No, actually, not so much. This Steamboat was getting up to 68, 69. I guess it was over 70 in that other example. So this, when you average a whole week, you don't get the extremes. But the point is that as you go downstream, it says distance from the divide, or different distance from the highest part in Steamboat Creek, going toward the mouth over on the right. It gets warmer and warmer, and then it hits Big Bend Creek. Doesn't show the temperature of Big Bend Creek. It just shows you what Steamboat does, and it drops from 68 degrees down to 62, and then rapidly starts to increase again until it gets even warmer than it was before it got to Big Bend. So, fortunately, it hits the North Umpqua River, which is tons of water and a lot more water for the amount of heat that hits it. So you're back to 65 degrees again. Okay, I mentioned graphs. These are just some examples. I'm not going to talk much about graphs, just to say that I saw this great thing on Science Friday a couple weeks ago, and got the URL here, that they had a couple of folks who'd done research on graphs, and they found that kids, adults, people of all age and education often make some of the same mistakes with graphs. Let's focus on this graph here, where kids were counting how many fish they saw, how many snakes they saw, how many dogs, how many cats. So the number up here, this is a count graph, and that says they saw 4 dogs. They counted 4 dogs. Well, if you, where'd my arrow go? Oh, there it is. I got to touch it right. The mistake that they found was the lower part are count graphs. They're showing that that same kind of graph, in this case, yellow and dogs, it'd be 30 of them, or I'm sorry, 15 of them. And this is just to show you that just to count 1, 2, 3, 4, 5 up to 15. The top of the bar is the number that you're counting. And same thing with, you could do it with counts, and 5, and 5 is 15. The point of their paper was that one good example of how people don't understand graphs is a lot of times means are graphed. It's different than a count. And on the left, if you just see that, it looks very much like the count graph below. And 1/5, 20% of the people that they showed this to said that all the values this was showing that there were 30 dogs, 15 dogs, or whatever count it is, when in fact it was a mean of somebody counted a low number, higher numbers. They counted as many as 28. They divided by the number of people counting and got an average of 15. But that's a very different thing. And if you think that nobody's ever counted more than 15 of this, then you misinterpret the graph. And so I don't know if the point of their paper was to say we need to teach graphs better, or realize that so often I see this a lot in newspaper articles and everything. People throw a graph up and they don't talk about what are on the axes. And some people think it's time, some people think it's money, whatever. So this is the link for that, and if you're recording, it'll be a recording. And it was only 12 minutes. You can go to it and either read or listen to it, but it's really kind of fun. Well, to get back to why people spend time in the outdoors, of course, you're going to see different things. You're going to see animals that are common around streams, like this Belgian kingfisher. These are 4 different kinds of crayfish. 3 of them are non-native and invasive. Fortunately, up at the higher elevations where the water is colder, this native crayfish is usually found here. We don't find many of the invasive ones up higher. We're hoping that doesn't change if the water's getting warmer. But I don't know if you can see that little white thing right there in the. But if you're in creeks, you'll see these telltale marks on, and the one with the white in its thumbs there is our native signal crayfish. It's too bad that the way the slide is put together. Oops. There. It says ring crayfish, but it's talking about the one below it. So these three are named there. And I didn't do this to teach you how to tell crayfish apart, but just that we see crayfish a lot in creeks. They're really cool and always gets people's attention. And this is fairly common too, rough-skinned newt. My hat. This. I had a rough-skinned newt on my hat. Now I just kind of want to remember not to lose my hat. Okay. So, yeah, rough-skinned newts are little aquatic salamander, and they have a larval stage that has big gills that stick out. And then we also have Pacific giant salamanders. They're scarier, but they're not. And these are just examples of the habitat that you have in creeks. Sure.
For the salamanders, do they prefer the warmer or the cooler?
Probably different among salamanders, but that one prefers cool water. And and I like the comment that you can't always tell how clean the water is by looking at it. Yeah. We'll get to that too. Yeah. So here's some different water, a little stiller, a little more algae growing. Some of the algae is streaming downstream. The water must be flowing from left to right. See these filaments being drug along. And this is a picture of Rock Creek. It's one of my favorites because it burned in the Archie fire, Labor Day 2020. And I have a friend who lives on the creek, so he sent me some of these pictures. The nice thing about Rock Creek is years ago there was a stream gauge there, so we had a history of what are normal flows on Rock Creek. You imagine that when something burns, that either there's going to be a lot less humus, needles and vegetation and leaves and needles up in the trees, a lot less of that to break the energy of the rainfall. So maybe the creek could be flashier, maybe you could flood your water after a fire. And you're particularly worried about flooding. I know probably everybody that was right on Rock Creek was really worried after the fire that there's no time to fix anything before it got before the winter storms. But we had a fairly gentle winter, both 2020 winter and 2021. So one of the reasons, one of the things that happens when the water comes up is that it's been a trickle all year long, or all summer long. Every time it rains in the winter, the water gets just a little bit higher. It gets up on some banks that it hasn't been to for a year more. Each time through the winter, the soils get more saturated. So the same amount of rain will boost the water up a little bit more. And each time the water muddies up until you hit the biggest one of the year, and then things start going down. And here's Nick. Oops.
Yeah.
Yeah. I missed the, there we go. Oh, see? Yeah. Yeah. It wasn't. There we go. So this is just a, when I said we were glad that Rock Creek had a gauge once, it had been discontinued. They're expensive to run. And, part of my job was finding money and convincing people to spend it to keep stream gauges going. I'd walk in somebody's office and they'd say, I know you want some money for a stream gauge. But with this reason to look at it again, I was very quick to put, until 2021, to get a gauge in, or the summer between the two. So now we have a stream gauge on Rock Creek, and it has all kinds of water quality information. So if you were just to Google Rock Creek Geological Survey stream gauge, you could get to a table that would give all the stream gauges in Oregon, and you can pick the ones you want, and you can pick water quality gauges, low gauges, or both. But you can see that the first storm, this is 2021 now, it was after Labor Day, but the next year. First it came up to 100 cubic feet a second, then 105 or 150, I guess, 200, starts getting up into 500, over 1,000, almost 2,000. Each time these little ones came up, they didn't muddy the creek up like we saw because it had already washed away that stuff. It does it a little bit, but after this point, I think that was the biggest flood of the year. Then things would settle down and it wouldn't be as muddy. And imagine if you're living on Rock Creek and you just have a pump in the creek and not much of a filter, you know when the water's muddy because you're just drinking bottled water. So I think it's a good time to talk about measuring. So monitoring is anything that you want to record videos. We talk about observations, picture. Of course, it takes a lot of thought of how often am I going to do this? Do I want to commit to doing it over time? Am I going to learn anything over time? Some things change that, some things don't. And really, I think that's what the first learning about monitoring and graphs and keeping track of things is noticing first and writing it down and figuring out, how am I going to use this? Is it worth the time? It takes trouble, it's time and trouble to monitor. And am I going to keep it? So I better get a notebook, and I better always put them in the same place. And old school, get a notebook, put it on my phone and get a file and do it in a systematic way. That turbid water, most of those soil particles are clay and they have a negative charge on them. So we can pretty easily, quickly measure something that will carry an electrical charge. Slow conductivity, and the rule of thumb is that total dissolved solids, or everything that's in the water, is about 65% of total conductivity. People have done enough of them that they've run. To measure total dissolved solids, you have to filter everything out, dry it, weigh it, and divide by the weight of the water, and you come up with the in there. And that has to be done in a lab, and it's pretty time-consuming and everything. But right when you're out there, you can stick with a little conductivity meter in the creek. And I don't know if I talked to you this, but I brought an example, a picture of one that costs about $20, and I use it for my drinking water because it came with the filters that we have. And here in Roseburg, we get there's a lot of, I guess I should back up. There's a lot of good things in water: calcium, magnesium, the things that naturally dissolved in water, even fluorine and iodine and stuff. They all, a lot of those have a negative, positive charge, and they will carry electricity, and they're measured in conductivity. The things that aren't measured, and in that bunch is clay. So clay has a negative charge on it. So if you get muddy water like this, you'll get a real high conductivity. And you get clean water, it doesn't have anything in it. If it has a high conductivity, it's something else dissolved. That's calcium or whatever. And you go to some parts of the, even further south of here in the Trinity Alps and where they have a lot of calcium, magnesium in their water, it'll be clear. It'll look clear, but the things that will carry a charge will measure on or register on a conductivity meter, but there are things that won't, and those are things like organic matter. Almost any organic molecule doesn't have any clear polar construction. It doesn't have a positive end and a negative end, or isn't all. So you could have tons of there are lots of fatty acids and stuff that's in needles and things, resins and stuff. It could smell like needles and wouldn't pick it up. And a lot of those things have color. So you might see something in there and get a low conductivity, but that's your clue that it's not. So maybe if you took kids to a creek or a pond, it might help to ask them what they see and what they would write down. They could tell you whether they think it's going to change. I think it might be a new idea to some kids that the water is a lot like the air temperature. If you're there in the morning, it's going to be cool, and if they're there in the afternoon, it's going to be warm. And that's something that conceivably you could see in a day in a field trip, long field trip, morning to afternoon. But in the time that you're there, you'll see the sun move. See, some places on the creek would be no sun, and other places don't have sun. So even the depth of the water, if you came back, you don't have to have that staff that I was pointing at in the first picture. You can just pick a place where you're going to measure the depth of the water, and then look at a rock and see where it is there, and keep that in mind every time you go. If you never measured the depth again, you know if it was higher or lower than that place in the rock, and you know it was higher or lower than the time you were there the last time. And it might be a new idea to kids that, it's water's pretty tame when you're there, but it can be screaming during the winter when you're inside, and you see one of those animals and you think, hey, that newt is there when I'm at home braiding my hair, or sleeping in the middle of the night. That newt has to have a place to be, and it is there, and it's perfectly happy. It does a good job. So wonder where it lives, what it's going to do. And, so I don't know if I've covered most of what we talked about. Do you guys have any questions of things that we could do that, or I could make up something?
Our campus is right on the Umpqua, and so we have access to the
Oh.
river, and we've taken our classes down there, so this will be really helpful tools for observation and things we
Great.
can talk about and discuss with them.
Yeah. And where is your school?
We're on UTC's campus.
Oh, yeah. Oh, yeah.
At Maple Corner Montessori, and so it doesn't take us long to get right down.
So do you go off that bluff down that steep? Oh, there's a road. That's right.
You go down to the very end of campus, there's a trail, a nice little trail that takes
Yeah.
you right down to
Oh,
a
yeah.
really nice spot where
Yeah.
you can do our
It's
classes.
vastly different.
Yeah.
So like you guys will see in fall when school starts and they could explore a little bit farther out, but then we went in the winter time to collect some water. And it was steep and muddy, and there's like all of you stay up there, and but it was
Did the same
vastly different.
students see those 2 times? or
Actually, there was different classes that
We've gone-
multiple times.
Good,
They've seen
yeah.
urban,
not?
rise and fall.
Grab my. Oh, here.
Do you want me to move on?
That's all right. No, I was just going to pull up one slide that I didn't have. Let me just send you.
Do you want me, so you have to turn around and share that video that you had shared? Do you want me to just
Oh.
do that? No.
Yeah, do we have time for that? That's a great, I really did forget about that. Good. Well, you're coming up with that. This is, oh boy. Yeah, so that's a picture of the water quality tester. It's just this little thing, and you push the button on and stick it in the water, and as I was starting to say earlier, that my Roseburg water measures 35 to 40 micromoles as conductivity, or
Yeah.
it actually reads out in parts per million.
Sorry,
Yeah.
can't see it because you're still sharing the screen.
Oh, okay, you'd have to see it in that little tiny, yes.
There we go.
There you go.
Oh, perfect.
Yeah, it's just yeah,
So this is, so the part.
sure. Northumberland Foundation.
This is sacred. It's sacred ground to our wildlife, it's sacred ground to our rivers and nature, and it's especially sacred ground for veterans who needs to find that healing and that connection to the wild. Our main goal into these wild spaces is to build our youth into future outdoor conservation leaders, basically, for tomorrow, to help continuing with that protection of our public lands, our fresh water, our wildlife. We bring these worlds together where a veteran serves a youth, and that youth serves a veteran and gives basically a purpose for us to punch through what we're dealing with.
That's the Big Bend hole.
And if you can find your time to kind of sit in solitude, try to allow the river speak to you in your own personal way. The idea with UMQUAD deployment is to build partnership with Pacific Rivers, who are doing the work to help protect the Umpqua River and the work that Frank Moore has put in. After war, it was that therapeutic piece that got him into a place where he says, you know what, this is important because of the fact that it's healing him. That healing mechanism that's tied to the Umpqua River, chasing wild steelhead, connected to his healing process, gave him that platform and that march to start marching to protect. And Jeannie, his wife, who supported him, she also has a maverick spirit. They've done this together.
You know, we can get along anywhere. Some of the species can't. They have to have some special areas to reside in.
Big, from a distance. Oh, you see, you see that?
The Steelhead Sanctuary really offers a new paradigm in forest management. This has never been done before. The Forest Service is directed to manage this watershed as a thermal refuge for wild steelhead and salmon.
I'm Charlie Dewberry. I'm a restoration ecologist working with Pacific Rivers up here in the Steamboat Basin. And we're, at this point, diving and counting juvenile salmon in Frank and Jeannie Moore Sanctuary. And so we divide the stream into riffles, pools, and glides. Why do we do that? It gives us a better estimate of the number of fish. Different species of fish are going to prefer either pools, riffles, or glides.
Riffle 1 by 3.
This is a standard method now, these surveys. In our context here, it's providing us, as I say, a foundation to begin to think about what are the restoration needs, what are the threats to these particular fish in these particular sites. We can put together a snapshots, and it shows us the areas that the fish are telling us, these are the really important areas. So those key places are absolutely central to maintaining the populations of fish.
It's great. I love it.
It was astounding, just to see how much life there is and really grasp the depth of the life cycle of the fish. It was deep. I feel really lucky and blessed to have had the opportunity to hang out with the scientists and Charlie.
Yeah, so a couple 1+s there.
When I'm out here, I let the river take over. I let nature take over. It's uplifting, it's spiritual, rejuvenates.
It became very therapeutic for me. From a veteran standpoint, that healing piece is something that we need. Sometimes when we come home, we don't find that home. We drift through, and a lot of us lives in shadows, and when we can start talking amongst groups in those same diverse groups, opens doors up for veterans to be able to come and experience the truest and the purest of nature is that medicine piece that we need. And when we can get that healing, even from a veteran standpoint, you just want another warrior to help fight and protect tomorrow's sanctuaries.
This land itself is healing from overharvest in the 60s and 70s and 80s, and we're just now starting to see a trend toward recovery. What we're trying to do at Pacific Rivers is recreate these kinds of sanctuaries in special places where there's wild fish, where there's cold water.
If we're talking about future sanctuaries, we need to start talking about bringing diverse groups into these spaces where they can become the advocates.
Not everyone is extended that privilege. Not everyone has that opportunity to be out and enjoy what are called public lands.
There's two sides to the access issue, and one is knowledge and the other is the actual physical access. And I feel like I can solve at least one of those through mentorship.
For me, it's for our youth, our next generation, to be able to come back and explore with their families.
I liked that video, and the reason I sent the link to Ryan was that just for the pictures on the creek and the monitoring aspect, I was always glad. I don't fish. I always blown away by the biologists who had to count fish because they never stay in one place. I have my hands full with temperature and flow, and so measuring in pools, riffles, and glides, and Charlie Dewberry said he's great guy, and they. I'm trying to think if there's some wilderness on the Umpqua, Boulder Creek, and up in the High Cascades, and then this 100,000 acres. The rest of the forest is 1 million acres. And I've always thought that the Forest Service was established for multiple use to be, you know, a variety of things. Well, for the first 50, 70, 80 years, we didn't do much for the recreation sanctuary side of things, and that gradually is balanced out. And I think they're kind of at a good place now. So plenty of logging going on, but there's also plenty of sanctuaries and refuges. So yeah, that makes you want to get out on the creek and see that picture. It's fun.
One of the sessions we had this morning,
Oh, sorry.
Getting out and observing and writing down what you notice, and so including like numbers of what you see. So
Yeah.
Data.
Exactly. Journaling, a diary, just blends right over into monitoring.
Yeah.
If you didn't write any prose, you know, any sentences, it'd be monitoring. If it was all prose, and you know, the monitoring wouldn't be part of it. Yeah. Yeah. Okay.